Hi there, and welcome to PIP from CCL-Forensics. I'm Alex Caithness, the developer of the tool, and today we're going to be looking at PIP, our XML and plist parsing tool, in a little bit more detail. PIP comes preloaded with a number of XPaths already written for a number of applications across PCs, an extensive library of mobile devices, and sat-navs. We're constantly adding further capability to our library, and we're very much open to suggestions from our users as to applications for future support. Despite this, while I was writing PIP, I was very keen to have the capability for users to write their own XPaths right at the forefront of the application. As a result, PIP is very much geared towards being able to write your own XPaths for XML files that are not already supported in the library. XPath is not a particularly difficult language to learn. It's simply a list of directions to the data that you want to get at in a particular XML document. As an example, today we're going to look at writing an XPath for getting the data out of a Safari cookies.plist file. Of course, with Dunk now available, I'd recommend using that tool for dealing with cookie files. However, before Dunk was available, we were using PIP internally for parsing these files. When it comes to writing an XPath, the approach is to try and determine in the document which are your individual elements of data. In the case of a cookies file, we want to find where each of our cookies are. In this particular document, we can find them enclosed within these dict tags here, here, and so on throughout the document. So the first part of our XPath needs to find how to get to the plist, then to the array, and then to each dict tag inside there. In PIP, we have the concept of the main XPath in this big box here, and then subqueries. The main XPath should describe exactly what we've just looked at, how to get to the individual elements of data in our document. As I mentioned, XPath is simply a list of directions. So in our case, first of all, we want to go to the plist tag, and then inside that, we want to go to the array, and inside the array we want to go to each of the dict tags. At this point, if we ran our query, in the results we would see the contents of each of the dict tags. Once you've arrived at each individual element of the data you're interested in, you can use the subqueries to start parsing out the individual parts of that data. For example, we want to be able to see the created time, the domain of the cookie, the expiry time, and so on. The subqueries are simply further XPaths starting at the place that you've already arrived at. So rather than having to write plist, array, dict, we can start simply from inside the dict tag. So let's start by looking at the domain. The data inside the dict tag is a key value pair structure. So you get a key followed by the value of that key, a key followed by the value of the key, and so on. So the first thing we need to do is locate our domain key. So we're already inside the dict structure, so the first part of our subquery will be key. We can then add these square brackets which allow us to define a filter or a predicate. And in this case we want to say the contents of the key is equal to domain. And we do this simply by going dot equals and then domain in quotes. So that gives us the content of that particular key tag. That's not actually what we're after. What we want is this string tag that comes directly afterwards. So to do this, we start with the slash as usual, but this time we first of all define that we want the following sibling, and that the following sibling should be a string tag. Running the query now, we can see that we see our domains. We can then give that column a name so that when we export the data, everything is correctly labeled. Let's move on to getting our created date and time. In this case, we're going to look to the key called created. So our subquery will start in very much a similar way. Key, square brackets, dot equals created. Once again, we're interested in the tag that comes after the key, so we say following sibling, and this time we're after a real value, a floating point value. Of course, these timestamps aren't human readable currently. They're stored in what's known as Apple time or Cocoa time, and this lets me demonstrate another feature of PIP, that is that we have built-in data converters for various different types of data. So in this field, if we move to our converter drop down here, and we're interested in Cocoa time, hit run query again, and now you can see that our dates and times have been automatically converted for us. As you can see, because of the structure of a plist and these dict tags, most of the rest of the data can be extracted in a very, very similar way. In fact, if we go to the library, we can find one that I've made earlier. For me, a lot of the power of PIP comes from the ability to write your own XPaths. So I'd very much urge users of PIP to give it a go themselves. There are a number of online resources that you can refer to. Some are listed here on the screen. A free trial version of PIP is available to download at www.ccl-forensics.com/pip. Thanks for taking the time to watch this video. If you have any other questions or want to make any suggestions for additions to the library, please contact us on pip@ccl-forensics.com.